Okay, all good. All right, everyone. So first off, thanks so much, for joining this conference, and welcome to my talk on introduction to multi-agent AI and MCP with Pydantic AI. So this is more of a technical session, right, for software engineers, backend engineers, and people who delve with Python. So I know you guys had a technical workshop. Earlier this morning with N8N and Landgraph. This is more on architectural patterns and some stuff you might want to think about when you're deploying to production. Okay, so yeah, in this talk, we're gonna introduce to you some prominent AI agent frameworks that are out there being used in production. We're gonna talk about the emergence of Pydantic as a staple tool in AI agents. And then we're gonna talk about my favorite tool, which is Pydantic AI, and the new trend right now, which is MCP, the Model Context Protocol. And along with that, we're gonna look into some multi-agentic patterns and how can you actually evaluate your AI agents in a production environment. Okay, so I think I was introduced earlier, but yeah, just a bit of recap. Hi, I'm Arnel Sargento from Davao City, Philippines. You can call me Nel. I'm a cloud engineer and Python developer. I work mostly on cloud native systems on AWS, and I'm the community lead of Durian Pi, Davao's Python user group. So yeah, I'm also AWS certified with these two AWS certifications. So in Durian Pi, we do meetups, workshops, and monthly events to essentially educate the Davaoenos, the people coming up in their careers on Python technologies, and more or less help uplift the state of tech in Davao City. Oh yeah, so those are our workshops and everything. So yeah, let's kick things off. Oh, I'm sure Joella provided a very great introduction to AI agents. So this is just a brief recap. So AI agents has emerged as a way for us to create and perform actions from the essentially the brain of the operations, which are the LLM, and allow us to have a much more efficient way in getting data from different data sources, like your database, your RDS instances, things like that, and to a much more specialized database for unstructured data, like a vector database. So you can look into having your AI agent perform like an email sending feature for you once there is like manual approval from a human user, right? With all of the email contents already created and automated for you with the context that you have provided. So those are the things that we've seen AI agents are capable of and much, much more. And how can we actually create these AI agents, right? There are a bunch of tools out there. So I'm sure you guys know of LangChain, LangGraph, and much more early emerged tools out there. But recently, there's much more that has popped up, especially from big tech companies. So OpenAI created their own agent SDK called the OpenAI Agents SDK. Um, Google come up with the agent development kit, which has like pretty inbuilt features with GCP. So yeah, that's something that you might want to look into if you're actually locked into the GCP cloud and Gemini and all of their great models. And with AWS, they created this, the Strands Agents SDK. So that's another model they've copied from Google, wherein here's our agent SDK. It has very good integration with our current services. If you want to be locked in the AWS cloud, yeah, use this. It is great. So yeah, those are some incredible tools actually, and I've tried each and every one of them, and it has their own strengths and weaknesses. But one thing that I've seen all of them have in common, especially with their most, let's say, um, very prominent feature, is the use of this library called Pydantic. Who here has heard of Pydantic? Pydantic, no. So how about sa JavaScript, there's this one schema validation library. So what Pydantic is just a schema validation library. It gets a JSON schema. It validates it according to your own definition, which is just a Python class essentially. And then it will throw an error depending on the JSON you have provided has adhered or not adhered to that specific schema. So you can look into something like this. Um, okay, wow, my code. So let's walk through this one by one. We just defined a user base model, which is a Pydantic model to say. And it has these attributes: name, email, age, website. So if you're designing an application with this data class primarily used, you're gonna define this, and then there's a validator function there that helps you to tidy the name. So yeah, that's our primary model. So what Pydantic does is, if you provide it with a JSON schema or a Python dictionary, it can then validate that. And if the schema you have provided does not adhere to what you have given, then it will throw a validation error, like an exception. So this has some incredible use cases, especially when it comes to microservices and your REST APIs. So yeah, but what happens here is that when you have existing, if you have an existing system that has existing services and existing code base, there is a chance that you just want to integrate your AI application into that existing app, right? And you want to go ahead and do the integration through what we call API contacts, through what we call having these specific schema that these microservices will talk to, right? So that's the thing with these AI agent frameworks. What happens there is, provide ka ng isang schema, and then I will tell my AI agent, okay, here's what I want, here's my prompt, and you will provide me a JSON object instead of just a string na pinoprovide ni ChatGPT. And that is enforced by Pydantic, right? So what's gonna happen there is that the LLM will use Pydantic to validate it. But if the LLM, for example, made a mistake, it will then regenerate and regenerate until it is adherent, compliant to the schema that we have defined, right? So it can look something like this. Again, same user model that we have defined. And for example, for this syntax for the agents SDK, we provided the definition, what model are we going to use. For example, this is GPT-4o Mini, one of the more smaller models. We've defined our prompt. You are a strict form filler. Extract a single user and return only a JSON object that matches the schema. So we just defined our user schema there. So we run that, and then if we go to the output and print that output, right there, it's going to provide our user model, and we can just convert that into a JSON object and return that to a REST API. So simple integration for our existing applications. All good so far? Yeah, but I know it's pretty technical, but yeah, um, that's where we come to Pydantic AI, which is one of the most bleeding edge agent toolkits out there, which has first class integration with Pydantic. So it provides you all of the features that these AI agents frameworks have provided for you, but in an open source way. So you can use Pydantic to go ahead and build your agents without the need to be locked into a specific cloud provider, or the need to be locked into a specific AI model provider. So there's no more vendor lock-in with OpenAI, no more vendor lock-in with Amazon Bedrock or Gemini, right? So that's the power of these open source tools, and I think that's one thing that primarily why LangGraph and LangChain has been so successful. So yeah, we're gonna see some code. So this is a QR code for Google Colab. I'm going to run through a bunch of sample code just for me to showcase the capabilities of these and provide you with some sort of glimpse into how do we actually integrate this with Python. So I'm just going to give you some time to scan this. So yeah, this is just a Google Colab already prepared for you guys. All right, all right. All good? Okay. Ayun. So yeah, that's for Pydantic AI. So let me just mm, let me just change my screen para duplicate siya. Um, mirror. There. There. All right. So this is the Google Colab that I've shared to you guys. So I'm just gonna extend this. What you see here is that in this Google Colab, we will. Sorry. All right. So in this Google Colab, you can see that we have installed a bunch of libraries with Python. So we've installed pip with Pydantic AI, Pydantic there, and a bunch of async libraries. So we're just gonna run that. So it's installing. It should be installed already here. But yeah, it depends sa internet, right? So as you can see here, it's installing. It's already installed for most of the libraries there. Just wait for a bit. Yeah, I think it's done. So up next, we're gonna set up Gemini. So I've already prepared here some API keys. So nakatago siya here. I will remove this after this talk. So para hindi siya ma-exploit. But yeah, I'm just going to put in the environment variable for the Gemini API key para makuha siya ng whole cell natin for this Jupyter notebook. And then we will now define our Pydantic models that we want to go against. So we will define this answer model, which is just kind and text. And we're going to define this fallback model with the same definition essentially. And we're gonna use this type model for a union for that. So we're just gonna run this, and then this is actually the main thing when it comes to Pydantic AI. It's actually very simple. You will just define your agent object, define your prompt. In this case, this is an agent that says return a factual answer model, and if unsure, return a fallback model. Simple as that. Just a demo for us to test what models are being routed to and against. So we're gonna ask it, what is the capital of France? And if it doesn't know the answer, we're just gonna go to a fallback. So if you run this, you're gonna see. Um, let's wait. Yeah, you shouldn't have rerun this. Loop is already running. Wow. Oh no. Yeah, but I think you've seen the output earlier, and that's what it does. So yeah, those are some things that Pydantic AI is capable of, and it intelligently allows you to work with schemas in a definitive manner. And right now, another thing that's common with most of the agentic AI frameworks is tool calling. So in this case, we have defined another agent, which we're going to say that you can call now, which is the Python standard function to get the current date for the current ISO timestamp and call it before answering the time sensitive question. So in this case, we're just gonna ask it what's the time, and we're gonna ask it again, call echo with text with hi. So in this case, it just used the current agents and tools that we've defined to perform its actions just like that. All right. So those are the key concepts when it comes um, to Pydantic AI. Now I'm going to present another concept that's been more of a bleeding edge when it comes to AI engineering. So just gonna reshare my screen, and it's this: the concept of MCP, the Model Context Protocol. So when you're dealing with microservices and agents, there, like in the past, there's this really tricky thing wherein you have to perform integrations for each and every tool that's available out there. So for example, you have a tool that's behind a REST API. In the past, like let's say a year ago, you will have to define the integration through Open API specs just for your model to understand when to use that tool, right? So, for example, here, before MCP, you're gonna have to perform a separate integration for Slack if you want your AI agent to send a message. You have to perform a separate you have to perform a separate integration for Google Drive if you want that integration, and so on for GitHub and the other tools out there. So it's a bit tedious, and there's no global standard out there for these types of integrations. So right now, earlier this year, there's this huge emergence and adoption of MCP, the Model Context Protocol. So this is essentially what I call REST API for AI agents. So it's a standard for your own, let's say, MCP client, which is your own agent app with Fast MCP or LangChain and other tools to communicate with external tools and services. So they can all communicate with this language, and all of them can use that with just that single interface. So only one integration, one standard for all of the tools existing out there. It's pretty cool and it's pretty nascent, but I think this is the future of what we're going to look into when it comes to building AI agents. And another thing, so yes, again, just to illustrate here, we have the AI host, which is ChatGPT, Claude, and your MCP server, which is the server where you're going to host what is the definition of these tools. So you can also create your own tools, right? And then attach those tools in your own implementation with data sources. So yeah, the possibilities are endless. And what the most prominent tool that is out there when it comes to building MCP service is Fast MCP. So yeah, we're not gonna demo that, but know that it's out there. Oh yeah, actually we're gonna demo it. Yeah, so I actually put it in the same. Um, yeah, I put it in the same Jupyter notebook. So this is again the code for implementing your own MCP server. All right. So Fast MCP here is the framework we're going to use to create our own MCP server. If you're familiar with Fast API, this is more or less the same thing, but with MCP. Okay, so we're just going to instantiate our own fast MCP instance. We're gonna call it MCP. And for this instance, we're gonna define a tool with Python decorators. We're just gonna define a tool for add, multiply, days between certain dates, and factorial, some common mathematical stuff. So we're just gonna run this on a separate machine, ideally. And back to our Pydantic AI client, we're going to define the URL where this MCP server is hosted. And then we're going to communicate with that. And with actual built-in integrations, it will know what are the agents available, what are the tools available for this MCP server. And just like that, fast MCP will communicate to Pydantic AI and or your agent framework, and then integrate with that on its own. So bunch of incredible implementations out there, and the possibilities again are endless with this one. All right. So those are some common technologies, the bleeding edge that we are seeing out there. Pretty nascent, but again, it's really good for you to be in this space as early as now. And up next, what I'm going to showcase is going to be more on the multi-agentic patterns. So this is the integration of how these things come together with multiple tools and multiple agents, right? So what you've seen so far is that we have a single client, a single agent that communicates with different tools, right? But there will be times that you're going to have your own distributed pattern. There are going to be times wherein you want an agent to call another agent, right? So that's one thing that we have seen out there, especially for much larger applications. So here, I'm going to showcase a bunch of patterns that are, I think Joella showcased a few of these earlier, but let me just showcase this. Yeah, first off, the router pattern, wherein you have multiple agents with different tasks, right? So, for example, you want an e-commerce, oh no, no, an edtech chatbot, right? And there are agents that you have implemented that are fine tuned for specific topics. So you have an agent for mathematics, you have an agent for English, you have an agent for history, things like that. However, you want your chatbot to respond as fast as possible, and you want your chatbot to be routed to an agent that is fine tuned to a specific domain, right? So what we're going to do is we're going to create another agent called the router agent, also called the orchestrator agent, which is just a very small na model that's fine tuned to just routing the prompt. So again, it's just going to, okay, here's the prompt from the user. I'm going to figure out what topic is this and route to the right agent for the job and then return the response. So that's one thing that we have seen out there. And yeah, mostly it's the smaller models that we're gonna use. Let's say mga instant na GPT-5, mga Claude Haiku, things like that. There's also the pipeline pattern. So this is more keen towards the workflows of the operation when you have multiple steps that you want in a certain pipeline. So we're going to look into a sample of this. Same in the Jupyter notebook, and yeah. So yeah, here's the router pattern. Again, we have different tools that are available and a bunch of agents here. So what we see here is that for math, we're gonna ask a math question, and we're gonna ask a QA question for the Hobbit, and we're gonna ask for a fallback if ever there's no agent available for the job. So as you can see here, it's going to use the correct agent for the job. So this is the code here. So this is not a multi-agentic example, but more of yeah, it's actually a multi-agentic example. So we defined two tools here, one agent for math, agent for QA, and it's just going to route to those agents depending on the job. And it's we're just going to define some functions on what to decide for those agents. And this is the sample again for the whole pipeline step, the pipeline architecture that we have seen. So again, we're gonna create two agents. One, this is an agent that allows you to create like an essay. So first off, what will be the requirements, right? So we're gonna ask the agent for requirements. What is the topic? What is the audience, and what is the target words, right? The length of the whole paragraph. So we're gonna extract the documents, the requirements from that. So from our prompt, we're gonna extract the requirements. We're gonna pass it to our outliner, which will only provide the outline of our essay. And then from the output of that outline, it can then provide a draft and run it into the entire pipeline, just like that. So mostly multi-step approaches into these agents. All right. And lastly, for the patterns that we're going to look into is this, the pattern for critique, right? So there are certain methodologies out there wherein two agents are actually arguing with one another. They will critique each other's work and figure out until a certain criteria is satisfied, which is the most optimal output to be sent out to the users. This is one of those patterns that actually take a very long time to respond, but it's very important to showcase this. So yeah, in here we're going to define an editor agent and a critique agent. So the editor agent will just create a draft and avoid some fluff with the output it has provided. And the critique agent is the one who's gonna score that and provide what is the rating when it comes to the certain metrics that we have defined. So here we're just going to run this improve function, which is just a loop essentially, and we're just going to define a maximum amount of rounds wherein we have to adhere to the certain target, right? So yeah, essentially this will run in a loop over and over and over again until the critique agent is satisfied. So those are the patterns that we've seen out there. A bunch more, but I think these three are the most critical for your AI engineering journey. And yeah, going back to this, this is the critique and editor pattern that we've seen from the code. And one thing that is a bit um, related to this is how we can actually automate the evaluation of AI agents in a CI/CD pipeline. So if your team is really focused on DevOps and has a culture that's akin to that, this is one thing that you have to look into. It's a bit expensive, not gonna lie, because you're actually using AI and mocking AI to perform outputs for you and evaluate that. So this is one workflow that we can look into. And yeah, um, essentially we have the agent's output and an evaluation set, and we're just going to compare the agent output and in the evaluation step against each other in a certain evaluation agent and return the output from there. And there will be like a red fail in the pipeline whenever the output of the agent falls below a certain standard. But yeah, those are the topics that I want to delve into in this talk. I know it's pretty technical, but I'm going to provide a bunch of code to help you get started. So this is a QR code for the GitHub repository that we have prepared for you guys. All of the examples and more are already in that GitHub repository. Feel free to clone, feel free to experiment with this on your own, and a bunch of instructions on the setup is already there. So yeah, feel free to get a look into multi-agentic AI with Pydantic AI and MCP. And yeah, I'm just gonna give you guys time to scan. All right. Okay, so yeah, that's pretty much it for my talk. Yeah. Another QR code, just my links if you guys want to connect my LinkedIn and my Facebook accounts. And yeah, thanks so much.